My fourth speaker is Dr. Sudesh Sivarasu. He's an associate professor of biomedical engineering from the Department of Human Biology in the Faculty of Health Sciences of University of Cape Town. And I enjoyed it very much already having a quick discussion with him yesterday. And I believe he will provide us an insightful presentation on the efforts of UCT to combat COVID-19, at least at the national level in South Africa. Prior to giving him the floor, I see now a question on the Q&A session that maybe he can reflect on. There's a question from Calvin asking, what can we do as a university, country, and African continent do to increase investments on healthcare? And we will be only able to beat disease by investing in research and development. We cannot just say consumers of health research and development. We need to research the development of better health strategies. So there was a question, I think, on how we link the research at universities well with healthcare improvement. Dr. Sadish, the floor is yours. Thank you.
Thank you very much, Sarah. I hope you can hear me.
Yes, I'm hearing you.
All right. Perfect. And thanks to all the previous speakers. It was wonderful to be in midst of some of the stalwarts in the field. So the previous question that you just posted is kind of a wonderful segue into my presentation. Primarily, we need to invest in more health infrastructure, and that has been, COVID is kind of a scenario where it has actually exposed all the gaps in the infrastructure requirement or we have for managing a pandemic like this, and it's kind of becoming a wonderful opportunity for us to go over that. And I must start by saying this. COVID or even the pandemic as such is there are two ways of responses possible. One is to buckle down because of the immense load that clinical load that a disease like COVID-19 brings onto the system. The other is to be resilient and be stronger than what the pandemic is. And mankind has always been resilient over all these pandemics, and I'm sure we will get over COVID-19 as well. And in a way, and the previous speaker was very rightly mentioning that we are in a situation where the supply chain is crumbled because of all the logistical restrictions. Now we are left out with no other option but to innovate on the ground. And I'm going to be presenting, I've made a brief slideshow just to show what the Medical Devices Lab as part of the University of Cape Town is performing in response to COVID-19. So let me briefly start with a slideshow and then go into details of my technologies. So I'll be presenting a very high-level information related to various technologies that we have developed so far. And the reason why I'm showing this is that we need to understand that being in Africa, we have to take lead in innovating solutions. And if we don't take lead, nobody else is going to support us in this whole exercise. And I think the onus lies on us to actually innovate and come beyond this pandemic. So there are a few solutions that I would like to share today, and primarily that would give. This is particularly in response to COVID-19, but I think what the key takeaway is that COVID-19 is going to stay for long, or if not COVID-19, something else is going to come. So we need to be prepared with the framework to allow us to innovate beyond just now and to plan long term. And so let me start with a very simple innovation that our team has developed. We call it the UZPwiser. So it's a simple face shield that one could use, and this is a first line of protection for against aerosolization. And so the principle is that when COVID-19 started, the whole world started focusing on 3D printed visors, and our team just got our thoughts around this, and we thought maybe if we want to expand the solution beyond South Africa, beyond some of the developing countries in Africa, if we want to reach to the entire landscape of Africa, we need to look at a solution that will be sustainable, that can be manufactured with something that is available on the floor, and that can be made with no specialist equipment. And the solution is UZPwiser that you might see. So if you look at the actual components of the UZPwiser, it's a transparent sheet which is going to be your visor element. There is a comfortable foam padding, which is an upholstery foam, and there is an elastic band which will allow you to have it secured around your head. And the materials to build something like this would cost you less than 10 rands. In addition to making it more look beautiful or look elegant, we have to make some modifications to it. But somebody can make this at the with all off-the-shelf components that is available, and build this completely at $50, close to $50 price. And the advantage is also that we don't need specialist skills to make equipments like this. This can be handmade in about 3 to 5 minutes. And the good thing is that we started experimenting this at a very early stage, and we rolled out a few units, and then we tested it in the clinics, and we got some impressive feedback from the clinicians. And not just standing by that, we just went ahead and made sure that we follow the due diligence. And for it might, this is a medical device, and it has to be approved by SAPRA. So we actually made an application to SAPRA, and this device is now SAPRA registered, and is now can be used across hospitals. So we are quite happy with the way that has gone. So the reason why I'm emphasizing on a project like this is that it's a very simple technology that can be built with something that is available on the floor, on the field, and it doesn't need specialized equipments. It doesn't need specialized manufacturing infrastructure. It can work on the ground. So we need to emphasize on solutions that can be sustainable. Not go with just the fancier terms or more high-tech solutions. We should go with appropriate technologies. So WHO recommends that we focus on appropriate technologies. What happens in most of our cases is that we jump onto technologies which are affordable without making sure that it works in the environment where it is supposed to be working, which is the hard terrains of Africa. A solution like this would actually address that gap, and it also offers an opportunity for job creation. So any self-help group could start doing this, and make a living out of this. And we need to identify solutions such as these to ensure that we don't need interventions of PPEs from outside. We can manufacture them with our limited infrastructure. That's one. This is our Ubuntu booth. So basically, this is now at the testing center in Curtis Care Hospital. What you might see is that it reduces the needs for PPE while doing the swab testing. And the advantage of our system is that it has multiple entry points that you see. You see one patient being tested here, and you'll also see on the other side, on the opposite side, there is another hand. So when this patient is swabbed and tested, the cleaning staff would come and clean this side. The doctor turns around and starts cleaning on the other side. So this increases the efficiency of how faster the testing as such can be done. And we have already implemented this, and there's like quite a positive feedback for a system like this. This is nothing novel, but it's about to build this. You don't need specialized infrastructure. If you look at how things have been done prior to using a booth like Ubuntu testing station, the doctors would wear a full-on PPE and go and stand in front of the patient, do the swab, and then send the swab for testing, take off the full PPE, and put on a new set of PPEs and go for another set of swabbing. So there are a couple of issues with that. One is it takes about 20 minutes to do the whole process. Second thing is the cost of the PPEs that get changed over every patient is massive. And if you accumulate like 200, 300 tests that's being done on a single testing station, the cost just goes, very high. So with this, you need very minimal PPE requirement, just a simple face mask would do. Everything else for the system is taken care of by the Ubuntu station. And the positive, we have been quite happy with the feedback that we have received so far, and it's been implemented fairly well. And we are working on something like a reusable N95 mask. There is a global shortage of N95 masks, so there is more detailed videos of this, but due to the limited time that we have, and I know Sarah might cut off me by in 1 minute or two, so I'm just going to be not presenting all the videos, but it is available on our UCT Health Sciences website, YouTube channels, and you can have a look at it. So this is to tackle the global N95 shortage. This is by using a simple section of N95 filter that goes into a reusable mask section. So how this works is you change the filter slots, whereas the entire mask, which is made with a very comfortable material, sits and fits better than your typical N95 mask. And after you've used it, you discard the filters, and you can clean this entire mask with the use of standard cleaning materials, or you can even autoclave them. The other solution is like a Perso, which is a personal respirator, which we have built from using off-the-shelf components that are available, and this gives you a constant filtered, HEPA filtered air supply onto the clinician. Two advantages: the clinician always has clean air, filtered air over them to breathe. The other advantage is that the positive pressure that with the airflow prevents the aerosol bacteria, the viruses in the atmosphere to come in and get contact with the clinician. So we have tried the flock swabs. So we have the 3D printed flock swabs that one could print with medical grade material. So if there is a shortage of flock swabs, we have these designs that we could use to print, and it might not make economical sense to 3D print them, but in case of a global shortage, we could definitely help in that case. And we have also built some mask supports. You see, clinicians really struggle with ear loop masks, and it causes quite a bit of strain on the ears. So we have built some mask supports that helps them to hold wear the masks comfortably for a longer period of time. And we were part of the national initiative called the National Ventilator Project, and we made an application to the National Ventilator Project, which won, which is around making a CPAP device. And what we have done is we have taken all off-the-shelf components that are available in the market and built this OpenAir solution, OpenAir CPAP solution, which is UCT's ventilator. I'm just adding a video.
Hi, I'm Edmund Vessels from Medical Devices Lab at UCT. I'm here to talk to you today about OpenAir, UCT's low-cost CPAP solution. Pretty much we identified this given the current global pandemic happening with COVID-19, there being a big need for non-invasive ventilator solutions around the country.
The idea behind the design was to come up with a low-cost, simple solution for the impact that COVID-19 had on patients. It started out being a more complex solution in terms of mechanical ventilation. This was before the National Ventilator Project, before the call for ventilators in South Africa, but we modified the design to come up with a simple low-cost solution. It uses off-the-shelf components. We are targeting home use of the device as well as potential hospital use.
When the National Ventilator Project started and the call went out, we were therefore ready to submit our initial design, which was actually a more invasive mechanical ventilator, in preparation for the need for CPAPs. We've also been working with CSIR and going to be heading their clinical trials on their side to test their CPAP solution. OpenAir, however, is an incredibly useful low-cost solution. It works with existing oxygen from the wall supply and a diaphragm pump. And we're currently looking to expanding this into a more home-based solution for anyone who can actually isolate themselves at home and still needs a ventilator solution.
And we are working on other projects such as the N95 decontamination systems. We're looking at possible uses of hyperbaric oxygen therapy for COVID-19, etc. So the point is that we have to innovate for scenarios like these, and we can't wait for imports, and we can't be waiting on PPE shortages, and we'll have to protect our clinicians if we want to support or if we want to flatten the curve. And the only way that we can do that is if we ensure that the innovations come within our local resources, and if it is sustainable, and if it makes a business sense, and can go for a longer period of time. That's where we should focus on. And pretty much I'm done with that. Sarah, thank you very much for the opportunity.
No, thank you very much, Dr. Sudesh. I was not intending actually to stop you at any stage of your presentation. I think you are, and the University of UCT is implementing what we call in the concept of resilience, operational resilience, the capacity of the state and also the state organizations as well as academia to take actions and try to respond efficiently to the crisis, and also to take crisis management approaches. I'm very much inspired by the advanced research and also projects you are implementing, and we really hope when all these virtual meetings are done and we get back to our normal physical life, we can maybe invite the university also to show this project to the strategic partners, the Economic Commission for Africa, the African Development Bank, because this is the value of also our role as EPRM to link academia and research organizations with development organizations, and we invest in a homegrown solution and also local industries. And also there's an interesting question on the medical devices are now available in the markets, or it's prototypes. This is from Amru Sukkar. There are two questions I also shared with him on his projects, and also there's an interesting question how we can if there's any proven strategies for managing the sharing of non-beneficial information. Maybe Dr. Sudesh, because he's also a professor, can give some reflections on these questions. Thank you.
Thank you, Sarah. Maybe I'll start with something which is much more easier. So which is around where are these medical devices at the present stage? So as you might have seen, the variety of medical devices that we have shown starts from very simple, low risk medical devices to more sophisticated, more high risk devices as well. So of these devices, we have been successfully been able to implement 3 of these technologies in the market, so which means it's in the clinics for usage, and we have been depending on philanthropical sources to get that out of the labs into the hands of clinicians who might need it. Other devices are presently under review with SAPRA. A couple of them are under review with SAPRA, and a few of the others are still under preliminary risk assessment in our labs. So the whole idea is that we have to understand the entire value chain of how to take a technology from being from an idea to getting it SAPRA approved to getting it out to market. It's the medical devices is almost like the pinnacle of engineering manufacturing, where you have to follow the due diligence throughout the process. And the African infrastructure or South African infrastructure is not necessarily well equipped for that, but the COVID-19 has actually brought in people from different disciplines come together. So we have aeronautical engineers who are working with us on maintaining product lifecycle management systems to ensure that that can go into SAPRA, etc. So it's quite a variety of technologies, and each technology needs to be reviewed and implemented according to the regulatory bodies' requirements. And on the other questions about why Ubuntu? I think it's about humanity, and it's about sharing the values of humanity. It's about taking care of the clinicians who are also working to save us from COVID-19 or treat us from COVID-19. So it's about the whole philosophy of actually sharing and the compassionate grounds that we serve other people. And I think it's using our science and technology to serve people is much more applicable and stages in times like this pandemic COVID-19. And going beyond just the technologies in terms of sharing information, I think this is one of the most important times that open science has become a topic of interest, and open source innovations have become quite more relevant than in the previous occasions. So I think more and more, even the African unions and all the scientific councils, we should start emphasizing on the facts around open science, the limitations and the advantages of open science, which is not really a huge talking point in Africa. I think we now going forward, we might have that being a big emphasis, and we should actually start focusing on open science. And I think with open science, a number of other things would also follow, and which would also come around open technology, open science, open innovations, etc. So with that, I conclude, Sarah.
Okay. No, thank you very much, Dr. Sudesh. I think we come up now to the end of this session. Colleagues, I only want to give a quick announcement on our survey. If you can kindly take a few minutes to complete a quick survey, which has been shared by a UCT colleague, Ms. Colin. It's in the event Q&A session. Just give us your reflections on how do you assess this session, and also the moderation and everything. Thank you very much. I think now we finished on time, or one minute late. I'm wondering if any official or expert or professor from University of Cape Town would like to give us just final remarks or conclusions before I announce the closure of this session. Thank you.
Hi, thank you very much, Sarah, for moderating that session, and thanks to our presenters. Very fascinating, and it's encouraging to know how responsive and innovative we have been as Africans. Some of the issues that were raised in the Q&A will be dealt with in a lot more detail in subsequent sessions. One, for example, was how is Africa being impacted, or why is the impact of COVID in Africa so different? And we got some initial responses, but the later session from 2 o'clock today will actually go into that question into a lot more detail, into the science, into the socio-economic issues, Africa's place in the world. So people who perhaps feel that some of their questions were not adequately addressed, given the time limitations, we will have an opportunity to go into that in a lot more depth. Again, just want to apologize on behalf of Professor Eddie Maloko. One of the things that we learned about this sort of technology is to, if you want to be part of the presenters, you can't access it via a phone or an iPad. You actually have to have the app on your laptop. And unfortunately, Professor Maloko was relying on his iPad. So that is what was the main reason why he couldn't connect. But the IT people are working on that, and hopefully for the later session at 2 o'clock, we will be able to have him on the call. So again, thanks everybody. Let me just see, there's a message that has just come through. Let me just see what this message is about. It's just to remind me again to thank our sponsors, Standard Bank, for supporting us for the webinars, for the webinar series for the next few days. And we really look forward to people joining us at 2 o'clock for a continuation of this webinar series.